Stanford University.
Okay, good morning, everyone. My name is Diane Wu, and I'm one of the student representatives for GCEP. I'm a graduate student at Stanford, and it's my pleasure to welcome you today to the Personal Mobility 101 tutorial. I'd like to introduce to you Dr. Sven Beiker, our speaker today. He's the Executive Director of the Center for Automotive Research at Stanford, or CARS. He received his PhD in 1999 from the Technical University of Braunschweig, and after that, he worked in the auto industry for over a decade with BMW at locations in Germany, Detroit, and Palo Alto. In 2008, he joined us at Stanford in his position as the executive director. And alongside his duties as executive director, he also teaches courses in the School of Engineering as well as the School of Business. So this quarter, he's teaching a course called The Future of the Automobile. So he's basically the perfect candidate to teach this small tutorial for us today. Just a reminder, the session will run until 10 o'clock. And if you could join me in welcoming Dr. Beiker.
Well, yes, Dan. Thanks a lot for the nice introduction, and thanks everyone for the warm welcome. And yes, some of the material that I am going to discuss with you here this morning is from the class that I also teach here in engineering. And it's really the topic that's very dear to my heart, the future of the automobile, or how I actually like to call it more these days, the future of personal mobility. And so what this will be is about 45 or so minutes. I really wanted to present some material to you, and then we said that we definitely wanted to allow for quite some time to have a discussion and see if I'm totally off with all of this, if there's something that you would like to discuss even further, or if I can learn from you, that you actually tell me that there are much better solutions than the one that I have to offer. So to get started, what I already mentioned, the class that I teach is still listed as the future of the automobile in the Stanford course directory. However, this call here I call the future of personal mobility. And why I'm making this distinction? Well, let's see, mobility, how I would like to frame it, not just for the purpose of this talk, but basically for the discussions that I lead in general. It's about the mobility device, and that's very often in the cases that I cover, the automobile as such. But then it's the mobility consumer. Because as was mentioned in the very nice introduction, I've worked in the automotive industry for quite some time, and I really appreciate the automobile as such a lot. But the automobile by itself is really nothing. Because the automobile, at least till today, doesn't really drive itself, and we will discuss this a little bit more. But the automobile itself does typically not really cause an accident. An automobile by itself is not really making a decision, you know what, I do all these short trips. You know what, I really drive in a very uneconomical way. You really need to factor in the driver, the consumer, and which is often then not just the driver, but also the passengers. So as I would like to see it, there's certainly some transportation aspect, but also the recreational driving is very important to me. Because the automobile is so much more than just getting people or goods from A to B. The recreational aspect and just still very often the joy of driving, but also so the agony of driving, where it's not just as nice as pleasureful as it should be. That also needs to be factored in. So because the automobile, you can argue, is maybe one of the most emotional consumer products. On the other hand, it's maybe one of the most regulated consumer products, and it's also one of the most expensive consumer products. So therefore, there are a lot of attributes that go with it, where I really like to talk about the automobile, but also how we use it, and therefore I'd like to call this mobility. Well, if we talk about personal mobility, there's this slide here from a very much appreciated colleague, Andrea Schäfer, who has looked at how we use our passenger miles traveled and how they split up over different parts of the transportation sector. And the red wedge that you see in there, basically for the last 100 years almost, you can say, if we talk personal mobility, then definitely here in this country, we are talking about automobiles. In blue, you see what air travel is, and in between blue and red, you see a little bit of mass transit. But if you look at passenger miles traveled, it's really automobile that gets people around. Now, that comes with problems, obviously, and I guess if I were to ask you what are the problems that we have from all this automobile traffic, you would probably mention something like, ooh, there's environment, definitely in this group, I guess, and there's resource depletion, and there's probably safety. But I wanted to start this discussion with some numbers. So if you talk safety, we are still hovering around 34,000 people killed in traffic accidents every year. In fact, these are the 2012 numbers. I used to have until very recently the 2011 numbers on there. There was 33,000 people killed. Now they're actually going up again. They're 5% up. Only if it's a very brief question, because we're going to have...
Is that global or national?
This is national. Yeah. It should say United States. Other than that, it's 1.2 million people globally. But anyway, so these are numbers that there are 90 people who will not wake up tomorrow because they are in a traffic accident today. And in more than 95, or in about 95%, human error is at least a contributing factor to all of this. And then pollution, you can come up with many numbers for pollution. I chose to use the health implications that result from vehicle emissions, and they are estimated to be somewhat in the order of $40 to $60 billion. It really depends how you slice this topic, but these are pretty large numbers where people obviously get problems because vehicles emit a lot of gases. Consumption numbers that you're probably discussing one way or another in other tutorials here and other talks as well. I chose to use the number that 10% of the global petroleum production goes only to light-duty vehicles here in this country. You see some other numbers of formulation of this statistic as well. And the congestion that I wanted to mention, the average commuter loses about one entire work week, so we say 36 hours every year because traffic is not as efficient as it could be. And in fact, it's pretty interesting. I also checked some numbers for other industrial countries worldwide. They are pretty similar, so that people really lose a lot of time because traffic is not as good as it could be. And the statistics go that about 30% of inner city traffic is basically because people cannot find parking and therefore need to circle the block in search of this parking spot that becomes very, very precious. So what are the solutions? Let's say the opportunities that we have, and these are the 4 topics that I want to discuss a little bit further. One is electrification, obviously, to really put more electric components into the powertrain, to maybe end up with battery electric or even fuel cell powered vehicles. Then there's automation, certainly here in Silicon Valley and at Stanford and the surrounding community. We're talking a lot about self-driving cars, autonomous vehicles, robot cars, and so on. I want to talk about this a little bit. Then there's communication, connecting vehicles to one another, connecting vehicles to the internet. And then there's what I want to call integration, how the automobile, the personally used vehicle, how that integrates with other modes of transportation. I would probably spend about, let's say, 40% or so of the time on electrification, and then the remaining 60% split somewhat evenly between automation, communication, and integration. This split basically comes to fruition because I really want to focus obviously on energy topics, and therefore you can obviously already guess where the big gains are to be expected regarding energy topics on this chart. So let's dive into it. Topic number 1, electrification, which basically is that we put in electric components into the powertrain. Electric motors might replace the combustion engine. Maybe a battery replaces the gasoline tank. And the expectations that we have that you will always see for these 4 topics, they are on the top right. These 4 challenges that we saw with safety, with emissions, with resources, and with congestion. And I'm not quite sure if electrification will help a whole lot with safety, but it will definitely help a whole lot regarding pollution and resource depletion. Question is if it can help with congestion. And that actually is a pretty interesting topic in itself, because if it's a situation right now where using a combustion engine powered vehicle for a short trip, that at least maybe some of us here in the room, maybe on a national scale, there might be a different fraction. But if we consider, oh, should I really get my car out not to just get bagels? Well, I don't know. But if it's like an electric vehicle and it's maybe not so bad to drive anymore, maybe we might end up with more traffic. So this is why I put a little question mark in there. I'm not quite sure if electrified vehicles might make a huge difference regarding congestion, but certainly, again, regarding pollution and resource depletion. We would have a lot of options regarding alternative fuels, and I'm sure we also have a lot of experts here in the room who can discuss with us whether we should go towards diesel or biofuels or maybe some sort of compressed natural gas or liquefied natural gas. But I really want to focus here on the red nozzle, on the red connector, which is the electrification piece in all of this, because there are a lot of topics where especially mobility becomes very important, where it's not just about the automobile, but also how we use it and how we would like to use it, and where maybe an electric vehicle might be different in its use case than a gasoline or diesel powered vehicle. So if we talk about electrification, I do not just want to talk about the battery electric vehicle, which maybe is the ultimate scenario, and obviously a lot of talk about this, but we should definitely consider this entire bandwidth from conventional vehicles powered by a combustion engine, then the hybrid electric vehicles, the plug-in hybrid electric vehicles, and the battery electric vehicles. We can maybe later on discuss also a little bit more about fuel cells as the ultimate scenario. But let's say we should probably take a closer look regarding the question, or at the question, how much electrification do we actually need, and how much electrification is good? And so if we want to answer this question, and I'm not saying that I have the definitive answer here right now, how much electrification is right, but definitely the questions that we should ask in a little bit more detail. This is, under which conditions will electrification actually help to slow down global warming, decrease the dependence on foreign or scarce resources, decrease air pollution, integrate into the electric infrastructure, and actually become the better alternative to consumers. And this is where maybe you agree with me, there is probably not just one answer. Because if you want to, you already see at the two topics on the top, if you want to do something about global warming, there might be one thing. If you want to do something about pollution, there might be a different thing. Basically, depending where you get your electricity from, there might be a very different solution that you might be looking at. To dive a little bit deeper into this, let's ask a little bit more the question regarding mobility. How are we using our automobiles? And this is a very interesting statistic I always find. Not sure, is this actually a laser pointer? I don't know. Let's use this. So this is over one entire week. It's from the National Household Travel Survey, starting on Sunday, 4 a.m., going to Monday, going to Tuesday, Wednesday, Thursday, Friday, Saturday, all the way back to Sunday morning. And you basically see where the vehicles are. The green is basically the vehicles are at home. Dark green is at another residence. Red is at work. Yellow is at school or church. And then there's a little bit for commercial usage, other. And just the dark blue is driving. So this is basically that we come up with numbers that vehicles are parked, not moving, 92% of the time. Well, you can ask the question, oh, how great of an investment is it if it's like the second biggest investment that we do in our lives, that we're only using it 8% of the time. But also, there's a lot of opportunity probably for charging here. But you can also take from this where you might say, well, you know what, vehicles are parked 92% of the time, so I can charge them 92% of the time. But you can also look at this light green wedge and really ask the question, should I really care about putting charging stations into a shopping mall? What about work charging and all of these things? Because maybe people end up charging at home most of the time, which is, if you look at some other statistics, that most of the charging that happens these days with plug-in vehicles is 80% actually at home. But also I want to put something else out here, what mobility actually is. What I just said, how great of an investment is it if you only use something 8% of the time, but you spend somewhat north of $10,000, $20,000, $30,000, maybe $80,000 on a vehicle, and you're only using it 8% of the time. And this is really where I, as an engineer, say, you know what, this doesn't really fit in an equation. It doesn't fit in a business scrutiny where you say, oh, you know what, that actually is a bad investment. Because all this time you're sitting here at home, you're dreaming of where you might want to go. You're making plans like next weekend, we get in the car, we go to the ocean, we go to the mountains, we really have a great time. You might not do it next weekend because the weather might be bad or you basically caught up on work or something like this. But mobility, especially with a personal automobile, is so much more than just getting from A to B. It is really about fulfilling dreams. And I'm not talking about dream cars or something like this. Very often why people, that includes me and maybe some of you as well, where people get a car because they want this independence. They want this freedom, they want this flexibility. My car is parked at home right now, but I could get in this car and just drive to San Francisco to maybe have a great meeting this afternoon, do whatever. I could go on the weekend to Tahoe. All of these things where we just say, you know what, I'm happy to pay for this, not just a little bit extra, but actually quite a bit extra, because that enables me actually to fulfill my dreams, or at least to just dream. Because if I don't have a car, then it's like, well, how would I go there? I have no idea. And that actually then translates into what we will be discussing a few slides later, obviously. What about this range that people really want for their driving? The range that people want to get out of a battery electric vehicle. It's not necessarily how much people really drive on any given day. It's maybe how much they want to drive and what their desire is. And that's then in this slide. Maybe some of you are familiar with this piece, which really is how much vehicles are driving average on a given day. And you see here the daily total travel distance per vehicle. We're looking at the vehicle because in the end the vehicle might have a range limitation and not the user. But this is here 100 miles, and you basically see from the cumulative daily distance where only about, let's say, the remaining, 8% again travel more than 100 miles on a given day. And if you read these two red lines in there, you basically find that 50% of all vehicles travel less than 20 miles on a given day, and 80% of all vehicles travel less than 40 miles on any given day. So therefore, the question then, or basically the statement typically is, you know what, 100 miles electric range should actually be enough. So basically people say, well, if we look at these statistics, can the vehicle get it done? And that vehicle that is depicted here would do a fine job for 90%, maybe 95% of the driving. But maybe these remaining 10 or 5% are the dreams, are the topics where people say, you know what, might not work for me because I do these trips, go to the mountains, go to the oceans every once in a while. So if people make a choice, they don't see these statistics. They think about everything else that they might be doing within the next 3 to 5 years when they purchase a vehicle. They might not do all these things, but they want to do it. And this is, as socio-economic as it looks and sounds, there's really a very strong connection to energy. Because if people don't purchase the more efficient car, they have a less efficient opportunity or less efficient solution every day. In other words, if the car is not appealing to the people because they think, I'm not quite sure if I can go out of our area if there's a natural catastrophe and I might need to stop after 40 miles because someone forgot to charge the vehicle. Might never happen. God forbid, hopefully it won't. But if people are not buying this car, they're buying something else, and that is a very inefficient and less economical solution every day they go to work. And therefore, we really need to think about how all this fits together, like the automobile in its characteristics, in its technical specifications, and what people actually expect from a vehicle, what dreams people might want to fulfill with their cars. So some numbers about this, and I'm sure, again, that quite some of you know Many of these numbers maybe have different sources, but I just wanted to list them maybe for further discussion later on. So there are two surveys. One was basically consumers in the United States on top, and then there was automotive executives in Europe. And they were asked, well, what are the challenges regarding electric vehicles? So this is about battery electric vehicles. And as you can see, the order is the same. The numbers are slightly different, but it's also interesting that the ratio between these, at least first three, is about the same. It's about range, the charging infrastructure, and the cost of the vehicle. It's basically something where people say, think, have the expectations or the impression, I pay more but get less. And that is really a tough pitch. That is really a tough selling proposition. If you have to tell people, you know what, it's early technology, it's good for the environment, you have to pay more, but you're much more restricted. So as long as we don't really have regulation, incentives, mandates that really address all of this, then people, and that does include myself, or maybe include some of you as well, defer this decision to get an electrified vehicle and basically say, not sure if the technology is ready yet, if it really fits my use case, because I'm outside the 90% group, and therefore I'm getting a different vehicle. And therefore, there's some numbers here that by 2020, 2 to 3% might be battery electric vehicles. These numbers have gone down over the last 2 years. Now they seem to go up a little bit. It's really interesting observation. I don't have this slide in there, but there's some interesting numbers in there. If you compare the market adoption of hybrid vehicles in the late 90s, early 2000s to the market adoption regarding battery electric vehicles, basically since the Nissan Leaf came out, you do find that the curve for battery electric vehicles seems to be a little bit steeper than for hybrid vehicles back in the late 90s. And there might be a lot of things that play into that. And one might be that us as society, we are a little bit more acquainted now with electrified vehicles, and that we say, you know what, that actually might be the next thing. But still, we need to see what happens after the early adopters got their vehicles, and if we can really, as we always say with these things, cross the chasm and really get this to mainstream adoptions. Because it's not easy to really tell people, you know what, range is not a problem. Because what we saw on the previous slide, people, again, that includes me, maybe some of you as well, have all these ideas, fantasies sometimes, what they want to do with their vehicle. So what can happen? And that is a slide, you see the many different variations. It's basically energy density per volume and energy density per mass. It's basically that a certain energy amount gets much, much lighter, so less weight in this direction, and gets much, much smaller, less volume in this direction. So basically down here, you're very heavy and very big. So that basically means a lead acid battery, which was still used in the EV1 at the very beginning, was obviously a relatively heavy battery, which basically means for a certain volume and mass, you don't get too much range out of it. Whereas if you move along here and you keep the same mass and volume, you basically get more range out of it. Or if you want the same range, you end up with a relatively lightweight vehicle. But what you can see here already, gasoline and diesel are up there. And you see with current technology, lithium ion, which you now find in basically every battery electric vehicle, and more plug-in hybrids as well. There's still a factor of 100 if you want to go with the same mass or same volume for gasoline or diesel compared to a battery in the vehicle, which you can say.
What is WH?
WH is watt hours. It's basically energy content, which you can translate into a range one way or another. Because a vehicle these days typically gets 5 kilowatt hours per mile. It's the other way around. 5 miles per kilowatt hour. That's the number. That's what you get on a Leaf, roughly. 5 miles out of 1 kilowatt hour. And so this factor of about 100 in between basically means if you wanted the same range out of a battery electric vehicle, your energy storage system, where you have today, like, let's say 15 gallons in your tank, it gets you about 300 miles. That translates into about 100 times the weight and volume. We're going to do more questions later on, only if it's really to not understand it, which was a good question. Was it US only? What hours was important? Okay, good. Thanks. So what this means, because even here we have like research frontier right now, which is metal, air, metal, oxygen, batteries, might get you an additional factor of 10, which would be great. But still, compared to what we know from today, the really behavioral change. Behavioral change in such sense, we have to understand that we might not have the same flexibility, the same autonomy with an electric car that we might have with a gasoline or diesel powered vehicle today. And of course you might say, well, what about charging? If we come up with a great charging infrastructure, and here are all the different levels of charging. Some of you might be familiar with it. I'm not going to go through all these 9 lines of different standards. Just note, level 1 is what you would get out of this wall plug over there. That's level 1 charging, so basically 110 volts. And then if you have your washer-dryer combination at home and you can use this for electric vehicle charging, that would be level 2 with 16 amps. You might be able to get it to 32 amps. Then down here is like the really fancy stuff, which is DC, direct current, fast charging. And the second last line here is the Tesla Supercharge, which is a great network, I think. And we need to see where this is going. And you can basically tell how much time does it need to charge a 25 kilowatt hour battery, which is basically what you have in a Nissan Leaf today, which on a good day gets you about 100 mile autonomy. So home charging just overnight might not quite top it up if it was totally depleted. But if you were allowed to get your Nissan Leaf to the Tesla supercharger network, you might be able to charge it within 15 minutes. Certainly there are then some other things that fast charging a battery basically degrades the battery. It might fade sooner, so you have to be careful with this. And you don't want to do it every day. But this technology is now being rolled out. But compare this to filling up a car at a gas station. And if you wanted the same range, let's say like an extra 75 mile, might take about 1 minute. Just put the hose in. Actually swiping a credit card, punching in your zip code might almost take longer than getting these roughly 4 gallons or something like this that you might need for 75 miles. And this is again where a behavioral change is necessary, because if we are used to this, basically replenish while you just stop. You don't really wait. You're almost like active while you're recharging a vehicle. You cannot check all your email while you are filling up the gas tank. And that certainly changes, because that becomes recharge while you park. And you might be parked in different locations. We looked earlier where the vehicles are at a certain time. And really these numbers are staggering. I find if we're talking about kilowatts that we are getting into the car with charging, for decades, we've been getting megawatts to our cars through the hose with gasoline or diesel into the tank. And that is just something where we need to understand this is a behavioral change. We just need to get into a different mode. We don't really need this 300-mile traveling every day, but we might need to plan ahead a little bit if we want to do this with battery electric vehicles. So there's a very early study that I'm conducting with a small research team here at Stanford that really tries to put this into numbers. Like, how would mobility behavior change if we went from a conventional vehicle maybe to a hybrid vehicle, which is actually no behavioral change at all, but a plug-in hybrid of some sort or a battery electric vehicle of some sort. And we discussed like 10 different personas. Persona number 1 is standing here right in front of you. And we basically looked at their mobility behavior over 1 year and how many trips they would need to skip with a certain battery electric vehicle because they could not do it without recharging in time. And you might say, well, I personally would need to skip 3 trips a year if I had a Tesla Model S. I might want to consider that. But I would need to skip about 8 trips if I had a Nissan Leaf. And you might say, okay, 8 trips. That's maybe not really life-threatening. Well, no, these are my trips like last weekend to Santa Barbara, or that's maybe a trip to Santa Cruz and back here from Palo Alto. That might not be feasible with a Nissan Leaf. But these are important to me. And this might be the reason why I'm buying a car in the first place. I personally commute by bicycle. And therefore, I'm basically getting a car for my freedom, my independence on the weekends. And each of you might have a different profile, but the assumption is that probably many of us might fit into these 10 personas. And that means like 30% of us totally fine with battery electric vehicles. It's not representative numbers, I want to point that out, but it really tries to put in a range, like there's a heavy commuter in there, there's a school teacher in there, there's a traveling salesperson in there. Who could actually survive with what kind of vehicle? And so this is what we need to understand. We really want to discuss mobility and what you can cover with a certain vehicle. Now back to these numbers that we saw. What are maybe other solutions for range if we won't get the super battery anytime soon, and also the charging network maybe is a challenge. So solutions that we have, certainly larger batteries, and this is, I think, where it's very exciting to see, obviously, how Tesla is approaching the problem. As you saw, I could do almost all my mobility profile with a Tesla Model S. You might want to consider that. But you can also put in a range extender where you have like, yes, a little gasoline tank, a little maybe a rotary engine, maybe a different engine that runs a generator, alternator, and then can charge the battery once the battery is depleted. So this would be like a Chevy Volt or a Ford C-Max Energy, or maybe a plug-in Prius, something like this. So that would depict more or less what these vehicles can do. But also, and that's definitely something I wanted to point out, some research that I'm also involved in that is currently funded by GCEP, which is the wireless charging on the road. So if you had a car that has this technology that can basically pick up a magnetic field from the road and then basically use magnetic resonance power transfer, you would be able to really transfer power to the vehicle as it moves along on a highway. And that means not that your battery is not being depleted once you're on the highway. So it might be something where you say, this infrastructure might not exist on every neighborhood residential road. Might not be even on every artery road in the urban area. But let's assume this is on every interstate, where really range is a topic. So you might have a relatively small battery in your vehicle. And until you get to the interstate, you deplete that battery. But then once you get off the interstate again, whether that's in Truckee or whether that's in Los Angeles or wherever, your battery is full again because you're getting all this charge while you drive. And then you can do your last mile, which might be last 10 miles or something like this, on a battery again. And that can be a pretty interesting proposition if you could charge while you go. We did run some numbers, which was the two top things where I said range extended versus a larger battery pack. And this is where we said, well, if the daily commute is roughly 40 miles round trip for many people, and let's just say we could cover this with battery electric only, that really means the cleaner the grid net gets, the cleaner the vehicle gets, and no tailpipe emissions and all of this. So if we assume this is the way to go, which I personally think is a good way to pursue, to cover the everyday driving in an electric fashion. But on the weekend when I go maybe, or want to go 300 miles, what can I do? I can put in the range extender, or I can put in a larger battery pack. These were the two options on the top. And we basically run the math, what the additional weight would be to cover the 400 to 300 mile, so 260 miles, with a range extender and a gasoline tank, or if we put in a larger battery pack. And these are the numbers in kilograms. So you would add an additional 132 kilograms of a gasoline tank, combustion engine, and some auxiliaries as well onto a vehicle, or more than 500 kilograms of a battery. Now you might say, okay, so what's the big deal? Well, the big deal is that you are schlepping around an extra 400 kilograms in this vehicle compared to that vehicle every day. And that is a problem, obviously, because you need to accelerate these extra 400 kilograms every day. There's more rolling resistance of 400 kilograms every day. And if you go uphill, you need to move these 400 kilograms every day. Question becomes, is that sustainable or not? And that is something, again, that I want to relate back to the dream idea. Why are people getting an SUV? Why are they getting a vehicle with all-wheel drive? Why are they getting a vehicle with 7 seats? Because it's this like, I might want to do it sometimes. And sometimes I actually do it. I might need the 7 seats because I may be the soccer father and I will drive everyone around to the next soccer game. But it's not every day. And then very often, some of us, sometimes I myself, point fingers, that is not an efficient vehicle. And they are driving this vehicle to work with all-wheel drive 7 seats and maybe a flatbed or something like that. But this might not be very different, where we say, you're moving around an excessive 400 kilograms every day. You're not using it. Is that efficient? Is that sustainable? So another solution that I do want to point out is this little video that I brought. Why not putting a little trailer with a battery behind a vehicle, which basically is, so there's someone who wants to go on a long trip. It's a European company. This is, I guess, someone who wants to go to Paris. And they basically get on the freeway, and then they're getting this range extender trailer. Well, it's somewhat similar to battery swapping models that we've heard about here in the Valley quite a bit, without the need to standardize each and everything. Because what you need to standardize is basically 2 things, what you will see in the next animation. The mechanic linkage, which is the trailer hitch, and the energy and probably some sort of data communication, which is 1 cable, which is probably much more easy to standardize than really an entire battery pack that you need to somehow plug under a vehicle and then need to make sure that it's safe, that it's really integrated into the vehicle structure and all of this. And I see some of you laughing, maybe because you like the idea, but also maybe because you might be thinking, oh, that's wacky. I'm not sure if I want to be seen with such a trailer on the freeway. And you don't need to have this trailer when you then go downtown, because you basically drop it off before you get off the freeway. But that is something, again, if some of us are maybe laughing like, I don't know, trailer. Because that is, again, the mobility aspect. We really say it's not just a decision that we can make based on a mathematical equation where we basically say, you know what, this is how it should be. This is where people might say, trailer? No, not me. And therefore, we really need to consider this. We are dealing with a pretty interesting behavior here, which is the behavior of all of us as humans, and then I get to Paris. And then really have to deal with it, because as long as nothing is mandated, I'm not saying that this should be mandated, but you could certainly mandate a few more things or incentivize, then basically the consumer decides and says, well, I'm not ready for this, or I don't like it. Some people were telling me about the relatively early on hybrid vehicles. Yeah, I might like to get one of these, but they're ugly. I said, so? Well, they're ugly, I'm not buying it. And there's just an opportunity that is missed. And that is really something that needs to be addressed with the mobility topic in general. So here's some numbers that we could probably discuss for the rest of the morning, but I decided to include them, which is a lifetime externalities that come from different vehicles that we saw on one of the early slides, which is a conventional vehicle, so a gasoline-powered average vehicle, a hybrid electric vehicle, a plug-in hybrid electric vehicle with 20 kilometers, they're metric in this comparison, 20 kilometers electric range, then plug-in hybrid electric vehicle with 60 kilometers electric range, and then the battery electric vehicle with 240 kilometers electric range. And they are looking at the lifetime externalities based on the average US grid mix, where the electricity comes from. A very optimistic case, which is all renewable energy, and a pessimistic case if everything came from coal-powered electricity plants. And this is a study that was done by Carnegie Mellon. Our dear friends on the other side of the bay at Berkeley were also involved in this. And they basically look in lifetime externalities in US dollars that come from different pieces here. So the green part is our climate, this greenhouse gas emissions. The other piece is the pollution. So this is NOx volatile organic compounds, sulfur dioxide, and all of these things that come out of the vehicle. And then they have a little bit about resource depletion, which is military interventions, and so on, that might need to be considered as well. So I'm not saying that every little tenths of a millimeter in these bars are correct or not. I'm basically pointing this out because what I find, this is one of the most holistic studies that has been done to date. I would like to see more of this happening, and I think it has to happen. And it's really to look at, you know what, it's not just about the climate. It's not just about pollution. It's about other things as well. But what you see in all of this is only if we really go to a totally renewable energy grid that then the battery electric vehicle is the best choice. Other than that, you really are fairly well off with a plug-in vehicle of some sort, or plug-in hybrid electric vehicle. And there are many things that go into this. So obviously these yellow bars, the sulfur dioxide pieces stick out quite a bit. Questions later, only if it's to understand it.
Well, the question is, did anybody look at natural gas fuel?
We discussed this later. They did not, as far as I understand. And the yellow parts obviously really stick out. And this is a sulfur dioxide that is emitted a lot in the battery production. And the larger the battery, and therefore the production is more energy and emission intense, therefore the more of these pieces you get. And this is again then the question, so maybe we don't need to go all the way to battery electric vehicles. Maybe there's actually some middle ground which is better for the consumer behavior because you can still go on your long trips and you have a relatively efficient and clean drive every day. And still, it might be a pretty interesting proposition regarding the sustainability, or in this case, the lifetime externalities. So this slide, I want to go through really, really quickly. This is just to capture the perception here a little bit. What I just said, battery-only electric vehicles might not be the ultimate solution if you think about consumers. What the manufacturers have to do, also they need to place their bets somewhere. What utilities need to do in order to charge all these vehicles, and then the environment, what we saw on the previous slide. It's definitely worth a consideration if maybe these plug-in hybrid vehicles are a pretty good solution. And therefore, I find it very interesting to see that many of these vehicles are coming up at the moment. So you see more and more manufacturers, for different reasons, obviously, going for plug-in hybrid vehicles, range extended, battery electric vehicles. So that might be a very interesting thing where I would not just say we have to go to all electric vehicles necessarily. So a little bit of a timeline that I have here. So if we look at the environmental impact and also on the consumption of these vehicles, obviously in the internal combustion engine only sector, we've seen over the last 30, 40 years, a lot of evolution and progress that has basically made combustion engines cleaner and cleaner. It's basically just one thing that you cannot get around. If you burn gasoline or diesel in your vehicle, you will always emit carbon dioxide. You will not get around it. So therefore, switching to a more electrified solution is in order. And we need to see if eventually we might end up with a fuel cell powered vehicle where we still need to find out where to get hydrogen or other fuels for these fuel cells for. But this is a little bit of an overview where we are obviously right here at the moment. We just got all the lithium-ion batteries into the vehicles. And maybe there's something about swappable range extenders, maybe swappable batteries. But it's really unknown where we are going with this. I personally expect that somewhat in here there will be a lot of action over the next, not just years, but maybe until 2030s. So the forecast, the prognosis from the energy information agencies are pretty interesting, that they say even in the year 2035 that the vast majority of all vehicles, all new vehicles, will still have a combustion engine. They put out numbers that 99% worldwide of all vehicles will still have a combustion engine. I find this number very high, but it really is something that it's not, we're now going all electric, putting out the gasoline motor, and then it's just vehicle 2.0 or 3.0, however you want to look at it. It's obviously a lot of middle ground to be covered. So in summary, maybe two trends that go in this direction. One is that in order to address the challenges that we have, challenges with environment, but also with mobility, that technology will improve, and that more and more powertrain components will become electrified. And we will see certainly better batteries, but also we definitely want to look at these range extenders and at the charge network. But at the same time, and I think this is probably half of the equation as well, if not more, the mobility behavior needs to be rethought, maybe needs to adapt. I would say it needs to change. On the one hand, that we need to consider more holistically how much do we really drive and what do we need a vehicle for. And maybe then there is something that you have your electric commuter vehicle and then maybe a sharing option for the weekend, or obviously with the power of the mobile internet and so on, that you can come up with some solutions where you say, okay, there's a car actually right here in front of me and I can use it and I'm subscribing to the network and I know that the range will be fine because I'm getting all this information. I think there's a lot which we will also touch on briefly in the very last part of this talk, where you can really use a lot of information that is available to actually then give people peace of mind that range might not be a problem and that the vehicle can get the job done. Whatever the dream in the long term might be, but for today, what your smartphone displays you just for your travel and mobility behavior for today, this vehicle will be right. So therefore, I think in this piece here, there are a lot of solutions as well. All right, I'm leaving the electrification piece now, moving over to automation, which basically is that the computer takes over, at least in part, the driving task from the human. And I do want to discuss this because, well, it's supposed to help a lot with safety. And since we want to focus here more on energy, I still said I would like to put it in because a more automated, a more maybe centrally controlled, a more advanced control of vehicles probably helps quite a bit with pollution and resource depletion as well. Maybe some of you know these numbers. If you were able to space vehicles closer together, closer following distance, you might take advantage of aerodynamic drag and lower the consumption of 20% of the following vehicle and even of the lead vehicle, because this is how aerodynamics play out. Even the lead vehicle would save gasoline or diesel as well. And this is why you see these road trucks that have this platooning of vehicles, which is being researched. Trucks basically space closely with one another. One thing is to really relieve the driver from the driving task, but also the efficiency piece as well. And with congestion, we need to see if we control vehicles more centrally, more smoothly, more forward-looking. Maybe we can avoid some of the congestion. But this is really where I want to be careful, because if driving is not a hassle anymore, we might drive more. Because I say now, you know what, I really like my commute by bike because it's really close and I don't lose much time. I might choose to move somewhere to the countryside, because if I don't need to do the driving anymore, I can do email while commuting to work and so on. So we have to be careful what we wish for, because through automation, we might end up with more traffic. So that is unclear. The thing is, there's a whole slew of automated vehicles, and you can probably not read all of it, and I have to say I still have a hard time really understanding all these definitions completely. This is just a slide that's taken from SAE International that was drafted this summer. NHTSA has some definitions that they put out, and SAE put out some names. So if we talk about automation, it's not just about cars that drive themselves completely. It's really what is happening from today, where we do most of the driving. Some of you might be familiar with adaptive cruise control that keeps the distance to the car in front of you, lane keeping assistance, these sort of things, lane departure warning and so on. So these systems will probably evolve into eventually maybe a fully automated, hands-off, feet-off driving scenario. But in between, there are a whole lot of stepping stones that we definitely should consider, because they can help already with a smoother traffic control and therefore less energy consumption, hopefully safer vehicles. So they basically talk about assisted partial automation, conditional automation, high automation, and full automation. And probably the things that you are thinking about when I say partial automation or high automation are probably not too far off by what that means. So I don't want to go through and read all of this. I rather want to discuss with you what are the questions that we need to ask here. And the questions that we need to ask here is basically, is it actually affordable to mainstream consumers? Because what we see today in research vehicles might not really lend itself to production vehicles. Will people feel safe? Do they trust these kind of vehicles? Do they actually want to be in a car that does everything for them and maybe not as good as they would do it? Can the driver really be released from monitoring the car? Because if that is a sales proposition, like you also pay more, same with an electric car, where you pay more, but you don't really get more because you still need to monitor the vehicle at all times, why would you do it? If you're not allowed to text while these systems are driving the car, then you might not want to purchase it. And how do they interact with all the 250 million vehicles that are currently on the US road network today? Do they actually mix with these vehicles? And then do we actually need infrastructure investments or not? Which basically is asking the question, very often these cars are called autonomous. You notice I call them automated. But the autonomous piece, like not really needing anything from the outside world, really being completely independent, not even like a communication link to any other vehicles and or such, is it actually possible? So therefore, where I say the vision and reality might be worlds apart. I do have a few videos here that I will just talk over. So this is from our CS people here. This is the vehicle Junior. This is a video from the DARPA Urban Challenge, where you see on top of the vehicle here a laser scanner. Just watch out for this thing, which is basically sending out 64 beams and getting 1.2 million data points every second, and basically therefore can follow the traffic rules. There was just a stop sign and had to pass or let every other vehicle pass, and then it would merge into traffic. GPS guided, obviously, the GPS waypoints basically tell the vehicle where it should go. And then with this laser scanner here on top, they also have radar, basically detecting obstacles, and then says, well, there's an obstacle, I need to go around it, I need to stop, I might need to find an alternative route. So this is, as you can tell, 2007, already 6 years ago. A lot of research has happened in this field since. It's now much more about really understanding context. Because what you can tell here, this can be mapped out, and you can really take time to really understand where the roads are. But if you put out a vehicle to consumers like us that we can purchase at a showroom this afternoon, you don't really know where this vehicle will be operated. So you really need to understand the context, where it's not just, this is the tree that was already there when I mapped out this road. This is the tree that looks like a tree, and therefore I don't want to go there. And here are some pictures from the radar images that they have. I don't want to go into that detail, but I do want to mention this other research that Professor Chris Gerdes, who is the, there he is, who is the director of our CARS program. They have this automated Audi TTS that they are now testing on racetracks. They went up with it Pikes Peak Mountain without any driver intervention. And this is not about automated racing series. It's not necessarily about man against machine kind of thing. It is more about what can machine and human learn from one another. And how do you create a collaboration between the human and the computer, depending on what each of them is better at. Where us humans, we are very good at perception, understanding context, and pattern recognition. Like, I've been in this situation before, I want to be careful. Whereas a machine is obviously very good at, could tell me right away how many people are in this room. But I don't know how many of you are here, I just don't drive my car into you. Whether there's 43 people in the room or 44, doesn't matter. I love the 44th person in this room. All great that you are here. But it's just a very different thing how people and computers perceive the environment. And therefore they are doing this to really test out what are the limits that a computer can control, but then also how do you hand back control from the computer to the human. Probably quite some of you have seen this. The Google car, very impressive. A visually impaired person, Steve Mahan, who drove to a fast food outlet to get some burrito, I believe it was. And I think it's a great demo. I could use other words than demo. But the question is if that sets us off in the right direction. Because this was already last year, and I think last year it was said within 3 years we will have this. I don't think so. I think it'll take much, much longer because, again, you can set up a great demo, a great presentation. Not that I could do it. I'm not smart enough for this. But to really understand what might happen on the road, that is much, much more. And here's a book or a picture from a book that my parents got in 1970. The book was called The Future, and it was looking at, of course, the year 2000, the frontier. And in the year 2000, we would drive like this. We didn't drive like this. And the thing is that if this is a vision, and it's typically like 20 to 30 years out, we also need to understand what traffic actually really looks like and what we need to deal with, where us humans just know, ooh, police, be careful, whether they're on a horse or not. Or where it's like, ooh, that was not really programmed into my system, but I better don't wrestle with it. Or like, ooh, sure, might be just a chicken, but be careful. And there are just so many unforeseen situations where you might say, yes, we do have 95% of all accidents. Human error is at least a contributing factor. But still, it is a situation, if we get the driver out of the loop, that doesn't mean that there's no human error. Because can you actually foresee everything that might happen? What about programming errors or even ethical choices? So this might be me and my buddies here on a nice bike ride on the weekend. And if a car has to make a choice on Kings Mountain Road, whether you crash into the Saturday morning bicycle crowd or you crash the car down the mountain into a tree in order to avoid the collision with the cyclist that is too fast maybe as I'm sometimes on my bike. That is an ethical choice that a human makes with an instinct and therefore will end up before court and everything, but it's understood there was like a judgment out of an instinct. But if a computer programmer needs to make this decision, sitting in front of a computer, basically say, if you see this, crash into the other options. That gets very difficult. Difficult also, some people say, what about the legal situation then in general? And here's some things that I borrowed from a researcher that's working with us at the CARS program as well, where probably some of you know that Nevada, Florida, and California have passed regulation regarding automated vehicles. And the question is what it means, but it's actually more important to look at what it does not mean. And it does not mean that these states have legalized automated vehicles. So it does not mean that we can just purchase an automated vehicle and just drive from let's say, Truckee to Las Vegas or something like this. It does mean that they put out a framework of regulation. And also, it does not mean that these vehicles are illegal anywhere else. It's just that in other states there might not be regulation. And still the legal status is not entirely clear because mostly they put out regulation for testing. And they give out permits that you can do the testing. And they do, at least in Nevada, they do put out something, okay, this is really for production vehicles later on to be sold. But as far as I remember, last time I checked, you could not get the form to actually apply for a consumer product that is a self-driving vehicle to get registered. So they put out a framework where they say, to the best of our knowledge, in the year 2012, Nevada did 2012, now there's more happening this year in other states, reflects that the legislator is getting involved in this, which I applaud, but it's still something where you cannot just say, these cars are legal in these states and illegal in other states. That's not true. You really have to read the fine print. And I really think, to summarize all of this, we should look at other automated vehicles. Yes, we might want to look at an automated vacuum cleaner, but maybe more this commercial equipment in the production, manufacturing area. And then these public or private shuttle systems, where I think a lot can come out of it, or other ground vehicles in the agricultural setting or in the mining industry, where you actually have already a high degree of automation. Well, why is that possible? Basically because this is a closed environment. You can call this is very similar to the demos that we're seeing today on a racetrack or maybe between Steve Mahan's house and the Taco Bell in his town, where you basically know what's going to happen. That you know the same person is not going to drive to Denver in an instant because it's about freedom, it's about independence. So therefore, you just have a much better understanding what your boundary conditions are. I think a lot can come out of these options here. A little private or public shuttle system in a shopping mall that basically goes between the department store, the cafe store, and maybe the parking lot, shuttles people around, and maybe every year it grows a little bit in its range, and then eventually might go on the surface roads as well, maybe on separated lanes or something like this. So as an outlook, what we want to be aware of, there has been quite a history of warning systems, assistance systems that we saw in the definition earlier, partial automation, and now full automation really is the big question, how far we can get with this. We are currently in a situation where we will see automated stop-and-go systems. This traffic jam assist, as some companies call it. Some call it super cruise, which might be somewhat in the same realm. A very specific driving situation where the system would help the driver substantially. But really, where probably the driver needs to monitor these systems at all times, or at least is there as a backup. If the computer fails, driver needs to take over, which is exactly the same scenario that you have on an airplane, where people always say, we have autopilot on planes. Why do I need to drive my car? Well, because it's a very different setting, because you have two highly trained, relatively well-paid professionals monitoring an aircraft, whereas in an automobile, you have someone like me who's not an expert driver, but really, how do you deal with these things? If I say, I want to let go and we want to go to sleep in my car, but in an aircraft where there's no kids at play in front of the aircraft, there's no deer in front of the aircraft, if there's a detour, you basically know it from the ground traffic control center, where there are two highly trained professionals typically monitoring what the thing is doing and reading out loud to one another what they are about to change. So we need to see how far we can get with this. Two main trends that I see in this direction. One is really we will have more and more driver assistance and eventually some sort of automated technology on our probably more premium luxury high-end vehicles that will then trickle down to the mass-produced vehicles as well. But really, I think we should watch out for what's coming from the other direction, which is this personalization of public transportation, like these publicly or privately operated shuttle systems, where we can learn a lot, because it's in a limited environment and you're just much easier by putting up the boundaries where these vehicles are being used, because if you have something that's running in between the shopping mall and the parking lot, no way that someone takes this little shuttle vehicle to Denver overnight. Topic number 3, and I want to speed up a little bit because I really want to leave some time for the discussion, communication. What if we could connect vehicles with one another and also to a centralized infrastructure? There you see green checks all over the board. So really, if vehicles can talk to one another, they can probably avoid crashes, very similar to aircraft. This is, I think, where the similarity or the comparison to the aircraft really lends itself. If someone's like, well, you climb, I descend, it's basically you go left, I go right kind of scenario with an automobile. You can probably do a lot in this scenario. If you control the entire traffic flow through a centralized infrastructure, you can probably end up with less pollution, probably use less resources, less energy, and probably have less congestion as well. Two ways to accomplish this. One is a centralized infrastructure. That can be really the cell phone network, where basically you put a little communication module, which might be your smartphone, that you can connect to your vehicle. And then you can share a lot of information, which can be something like there was an airbag deployment on mile so-and-so on Highway 101. Therefore, everyone else, be careful on the same route. It might be, ooh, my ABS just kicked in. Everyone else, be careful, it's slippery on the road. Or it might be something like, there's a lot of slow-moving vehicles here. Everyone else seek a detour. And you can use the same concept also for entertainment purposes or information purposes that you see here as well, which is important to note because a communication network just for safety purposes has been studied over and over again is not a good business case, because people don't really want to pay for something that they might want to use every 100 million miles that they get in a fatal crash. They want to pay for their Pandora or for their media streaming of some sort in the car today. And therefore, we need to couple these two topics, which is why the other piece is having a relatively hard time, which is DSRC, dedicated short-range communication, which is the current trial in Michigan where they have up to 3,000 vehicles equipped with Wi-Fi technology. Vehicles can really talk directly to one another without necessarily a centralized infrastructure. Where you can certainly do the same things, where there's an airbag deployment, you should have enough range to warn other vehicles. The nice thing about it is security is much better. It might be faster, might have higher bandwidth and so on. But really the thing is you probably need both to really cover the cellular aspect, like what are the larger implications in your area versus what is the more immediate near-term implication that you probably want to do with Wi-Fi. If we wanted to summarize this a little bit more, let's maybe take a look at this. What we have already, it's not that the whole topic of vehicle communication is entirely new. If we look at cell phones, then they started actually as car phones. And through this, you obviously have already a communication link in the vehicle. And now this is growing and growing, and we might go like an in-car hotspot that we have already on some of the higher-end vehicles. And more and more of this is being used for service updates. Actually, we do have the first companies that are sending wireless software updates to vehicles and so on. And it might end up being some sort of an internet of cars. Whatever that means, it's a little bit of a buzzword, internet of everything. So the cars might be included in this. We certainly do have some satellite, which is more a one-way communication for vehicles. And then we need to look at the Wi-Fi option here, which might be a public Wi-Fi or maybe a private Wi-Fi that's only established in between the vehicles, where you can do a lot of this vehicle to X, so vehicle to everything communication, but certainly some sort of a vehicle to vehicle that we might see at the end of this decade being rolled out, being mandated. This is again where a mandate is very important to really get to relatively quick fleet penetration very soon. So in summary for this communication, again, two directions. One is we really need all these apps in the car to turn it into a viable business case, because we want our media experience, we want our connectivity experience that we are known from our smartphones, from our desktop computers, from our computers at home. We want the same experience in the car, and that might pay quite nicely for safety applications as well. And then the private network, a Wi-Fi enabled network, to really have a very, very good link literally for safety applications. Real quickly, just to summarize, to talk a little bit about the fourth topic, integration, which is really how the automobile fits into all other mobility nodes that we have. There again, I'm not sure if that helps a whole lot with safety, but I think it can help a lot with pollution and resource depletion and congestion as well. Because that is something, if the automobile is really part of a larger infrastructure network where you just know driving your car right now to San Jose is not a great idea. Here's the facts, but here's your alternative. If you go to Caltrain station, you can park your car there, parking spots already reserved, and you get maybe a car when you get to San Jose downtown, or maybe you get some sort of other mobility solution. If you just knew through, again, the power of the mobile internet that this is just a better solution, that you're stupid if you're not doing it because it's guaranteed that you will lose 20 minutes, then this can work actually quite nicely. And also then get people to use less energy, and obviously that then causes less congestion as well. I do have a few more slides on all of this, but I don't want to go through all of this in detail. I just jump ahead to the two trends that I always have. But I'm not sure if we have two trends here, because I'm not really sure if this is something that's going to change, which is the automobile as a status symbol, let's say, basically as a personal expression of one's identity. It doesn't really seem that this is going away completely. And also that people really want to have an automobile to experience the freedom on the weekend, to fulfill their dreams. I'm not sure if this is completely going away. We will make these slides available as a handout, as a PDF, so you will find in there, I had a few slides where it's like young people getting a driver's license later, people maybe are driving less, but it's really an argument at the moment among the people who deal with statistics if it's due to the economic downturn or if it's a larger effect. It really seems to be something where it's definitely something got going, that the younger generation has a harder time giving up the internet than giving up a car. But still, once people then get into the 30s, things might change once they have families and so on. So we really need to see how that is playing out. But there's definitely something that the automobile is not just the only mode of transportation. And this is where I find car sharing, carpooling, even peer-to-peer car sharing and so on are very important options where we just need to experiment with it a little bit as society and actually figure out, you know what, my car is now parked at home, which is 10 minutes by bike to get it. But there's a zip car, basically 2 minutes walking distance from here. Why would I get my own car if I wanted to go to Mountain View, first ride my bike there, try to get around campus, just get a zip car. It might be much easier. Plus, I get to drive something different every time. Where I'm like, my car, I like my car, but I also like to try out other things. But it's really something that we say, you know what, sharing is not bad. And maybe even not having your own car is not like a bad status symbol, like, oh, probably cannot afford a car. It might be more something like, that's innovative, doesn't have a car. So the people probably still want to have access to the car, but they don't necessarily have to own it. So there's probably a lot of things that are coming up. So my ultimate vision for all of this is basically this. This is everything combined, which is an electric and probably, hopefully, wirelessly powered vehicle, which is automated, including the infrastructure that you need for it. I think it won't work without infrastructure. It's connected via Wi-Fi and cellular for safety and also service and entertainment purposes. And it's probably some sort of public and on-demand system. But to be clear, it's not a one-size-fits-all. So we really need to consider these things. One is, what population density are we looking at? And what is the infrastructure that is available? So if you are somewhere in Rocky Mountain National Park, it might be very different than Tokyo downtown. And therefore, we really need to figure out what the best solution is. What the automobile used to be, like a one-size-fits-all, like your maybe 7-seater with all-wheel drive and large trunk capacity and so on, that you also drive to work. Maybe these days are over. That is really more like an, let me really say, educated choice in the interest of resources, energy, and hopefully more enjoyable traffic in general. I was running a little bit over, I'm sorry, but we still have quite some time for questions. Thanks for your attention. Thanks.
So talk a little bit about the terminology on the different flavors of hybrids, and whether drivetrains are mixed gasoline, electric. Talk about those combinations. You had a bunch of terms.
Yes. Yeah. Let's see if I can find the right slide here. I think it was...
There was the one that showed the different things coming. Yeah, right, okay. But it was
this? Oh, are you talking about the timeline?
Well, you can do this, but you had some other things. You had a light hybrid. You had a range extended. Yeah, let's see.
Was it this?
Yeah, that's the one there. Why don't you just tell us about the current terminology, the different flavors, and like I say, whether or not there's the gas engine is just charging the battery, providing.
Okay, sure. Well, let's see what we have here. So basically how I put together this chart, this is the first full hybrids, which is basically the Toyota Prius and then the Honda Insight. And then we had a few mild hybrids that I would call the Honda Civic hybrid, which is basically a little bit smaller electrification or smaller electric motor on the powertrain. Still helps significantly with start-stop and something like this, but might not be able to drive the vehicle under electric-only conditions. And then the plug-in hybrids that you obviously hear a lot about in the news. Basically, these goes what the size of the electric motor is and what the size of the battery is. So if you can get an electric-only drive, you might know with the standard Toyota Prius, you can get about 2 to 3 miles, best case scenario, electric drive, which is then only up to 25 miles or 20 miles per hour or something like this. And so I think where a lot of this is happening, that I really want to say society, which is not just us as consumers, but also the industry and probably also the decision makers, policy makers, need to figure out what is like maybe not the sweet spot, but a very attractive solution for consumers and also for the environment and energy, obviously. And this is really a little bit of experimenting with battery sizes, with motor sizes and so on, that you really see how much battery electric range do you actually want. And this is where all of this comes in, basically from they're even micro hybrids, which is what you might call like a little bit larger alternator that can basically recharge the battery a little bit. Then you go to the then you go to the mild hybrid, which is a separate electric motor with a somewhat sized battery, and then the full hybrid. It's really how much of the driving power is coming out of the electric path. I think that's, not sure if that answers your question, because I thought these terms were relatively well understood. But
well, the reason I asked was I've seen the definitions seem to change some over time, or some of them sounded more like marketing than.
it was definitely a lot of marketing. Yeah.
And I just wanted to know
Okay.
what they meant these days.
Yeah.
On that, how do you describe the Volt versus the Prius? Is there the Volt just charges the battery and all the
Well, there's a lot of there's a lot of debate. I would call both plug-in hybrids, whereas the Volt to me is a serial hybrid, and the plug-in Prius still is a power split hybrid. But the Volt actually has a mechanic linkage under certain highway driving conditions that the combustion engine drives the wheels mechanically, which is a topic that is a lot of controversy, that some people just feel that they were deceived because they thought they would get like a real battery electric vehicle. I, as an engineer, say, well, how much does it matter if you get a good mileage and a good range? So what, whether there's a little clutch in there or not? I personally, people might argue with me, but I personally would put the Toyota Prius plug-in, the Chevy Volt, and the Ford C-Max Energy in the same category. These are plug-in hybrid electric vehicles to me that have a different range, where the plug-in Prius, I think, has about 12 miles electric-only range. The C-Max Ford has 20 miles electric-only range, and the Chevy Volt, something about up to 40 miles. But it's about the same category, I would say. You had a thing.
If you could comment on social transportation tools, if you were to consider two networks, flows of vehicles that have positions and paths, and flows of people with schedules and destinations.
Mm-hmm.
So it's somewhere at the intersection of high-tech hitchhiking,
Yep.
casual carpooling using a social trust network, but moving more people with fewer cars.
Yes. I like the high-tech hitchhiking term. I did have one slide in here that I know it's not complete, but it's really about vehicle ownership. Who owns the vehicle that is being used, and what is about the social interaction that you have and all of this. And there might be here with carpooling that has been around, as far as I understand, since World War II, back then for different reasons. But where you basically needed to make a phone call or register in a list to actually get a carpool. And now basically you can select it from your smartphone application. The challenge with this is that it really needs a certain size. It needs critical mass. So I've been discussing this topic a lot with one of the founders of Zipcar, Robin Chase. Maybe some of you know Robin, who then moved on and founded first in the United States a social media combined with carpooling platform. Didn't really work that well because they couldn't really get it beyond critical mass. And that is just a situation where you say, if it's excuse me, if it's not beyond critical mass, then it is something there's not enough offers. And then there are not enough people checking it, so why should I offer if no one wants to ride with me? And the other way around, basically. It's a little bit of a catch-22, but it really is something through the smartphone that it's much, much easier. But also I want to say there are actually quite a few different apps out there that are competing with one another. If you could combine all of them, you might get beyond critical mass much, much more easily. But it's really important. Mm-hmm. David goes next.
You had a table of different types of people and their driving interests and how different cars.
And I was in there as well, right?
I think you were, yeah.
I was number 1. Should put me number 10, but yes.
So my question is, I'm curious if how does, say, rare load increase for a personal use vary? So if I'm somebody who owns a boat or a trailer, and every once in a while I like to haul that up to the mountains, and an electric vehicle or
Yes.
can't offer that kind of load capability as opposed to range capability.
Yes.
How does that work?
Well, it is in the end the same thing, because you tow around a lot additional mass. It basically shortens your range, and that needs to be factored in. It's a very important point. Maybe not by the numbers how often that happens. It might be in the very low single-digit percentage, maybe even below 1%. I'm guessing. But you're absolutely having a great point there, because this is why people might choose like a vehicle with large towing capacity that they are driving then to work every day, which they say, you know what, I have this boat and I need to get this boat to Santa Cruz and I have to get it out again in the fall or something like that. So probably you cannot do it with an electric vehicle. And this is a very important piece, again, why people making a certain decision for a vehicle, and then they are locked in for the next 3 to 5 years. Where it could be something like, I really like this term, high-tech hitchhiking, where they can say, you know what, if all of us together in this room had access to one vehicle with a great towing capacity, that might be enough. Because you might only need it 2 times a year. And this is where car sharing should not just be seen as something like I get a zip car or something like this. It should really be seen like it's a very convenient way of renting the vehicle that you need for one particular use on one particular day. And therefore, if that's a vehicle with high towing capacity, I'm going to have my buddy from high school over next week with his family. My 4-seater vehicle will not work for the 5 of us. So getting just a 5-seater for 2 days, I have to rent a car now, which is always a little bit of a hassle. I live in this apartment community just off of campus. If we just had a few vehicles to share, it would be great. So I think there's a lot in this, but in these numbers, I have to say, we only assume that you're basically moving more or less the same mass around every time. So if, I'm just guessing, let's just say that persona number 8, wherever my point is. If persona number 8 maybe has a boat, I have no idea. They probably would have told us, and then persona number 8 maybe still could not do all of the trips. Important point. David.
Back to your hybrid slide, hybrid and EV electric vehicles.
So this timeline?
Yeah.
Yep.
Should we be careful that there's lots of potential for disruption here? For example,
everywhere in all of this.
Yeah. RPE has this CNG project for storage and engines, and then we've got these very advanced motors like eco motors and rotary wings engine and so on. Things that could come in and disrupt this.
It's true. That's also what John was pointing out. What about natural gas? So this is why I said at the beginning of this piece, I'm only going to talk about electrification, because in electrification, this range topic is obviously very important. There can be disruption in all of this, and maybe in this topic in particular. Still with natural gas, it's a very important topic, and we've been discussing this quite a bit in the transportation seminar on Friday afternoons. I mean, if you look at it, in some countries, South Europe, for instance, is relatively well-established infrastructure for natural gas. Not so here. And that is already somewhat similar to the electrification piece. If you don't have enough charging stations, then while getting one of these cars, same with natural gas here. Also, I want to add same with diesel vehicles here, because you don't get diesel at all gas stations around here. So it definitely is something. I personally see a lot of merit in natural gas powered vehicles for resources questions, but also for pollution mitigation. But it's again, this is why I wanted to point out at the beginning that I like to talk about mobility. As an engineer, as an environmental scientist, we might just say, you know what, natural gas. Everyone should get a natural gas car. But the mobility piece is like, ooh, I'm not really sure where to get natural gas except at SFO. And that makes it complicated. And that definitely, I mean, we do have a certain infrastructure at the home already for heating. So, but that was your point, John?
I was going to make is I think one of the interesting psychological aspects of some of these alternative vehicles, whether it's an electric vehicle or a natural gas vehicle, is people to conceptualize that they could recharge it at home rather than go to a centralized station of some sort. And that, I think, is what's so interesting about this thing that played out in the New York Times, where the auto reporter drove the Tesla car and parked it overnight in below freezing weather outside, yet didn't think that maybe he should plug it in while it's parked, right? Because in his mind, the only place to recharge it was at an electricity station, which was a designated place. And of course, the battery, when it's cold, loses capacity.
Yep.
This is not a technical question, but it's a psychological thing.
Yep.
I think what's interesting in these mobility things is how many people would say, it's great, I don't have to go to a gas station. I'd rather just put the car in the garage, and tomorrow I don't have to wait time.
That's right. So this is why this slide actually is really important to me, that we need to adapt to these limitations, but maybe also see the chances in it. Because I did maybe overemphasize a little bit too much. You pay more, you get less. But sometimes you might get something different. And it's exactly right. So you might not need to go to a gas station every other week anymore. Maybe you just go there every half year or so. So what I hear from some colleagues who do have a Chevy Volt, I mean, they are happy because they only go to the gas station once a quarter or something like this. And they are concerned if the gasoline gets bad in the tank. But I understand that the GM people did a fine job that this is not happening. Yes?
I just wondered if you could comment a little bit. We've heard in some of the other presentations here that the U.S. has got a really strong energy infrastructure, and it's been around for a long time, so it's hard to change the energy infrastructure. Same thing with the transportation.
Absolutely.
It's probably the most advanced in the world, right? So what about other countries, maybe where they're not as far along? Would some of these things be a lot easier?
Well, I definitely think so. So, I mean, if you are about to establish a transportation network and with that an energy supply network, you might not choose to go with gasoline and diesel only. It might be a very good consideration to maybe deploy a natural gas infrastructure. And also, if you are in a very limited environment, maybe if that's an island or something like this, hydrogen might be a good solution as well. So it definitely is something. In a way, we are stuck with this system. And we are stuck with this system because it's still relatively affordable. Now I understand that actually 44% of the petroleum that we're using in this country actually comes from the United States. And this number is going up for reasons that are being discussed in other tutorials here at this symposium. So why change? And that obviously strengthens the existing system even more and makes it harder for the newcomer, so to say, in this game. And I'm personally concerned about this because I listed a lot of the challenges, and I basically went by there's pollution, there's energy, there's climate and everything. So it must not be, or doesn't have to be like one single thing why we go electrified, why we go automated, something like this. But there are a lot of different things at stake that we really need to consider. Like, yes, the transition probably is not easier. But guess what? We ended up with the situation that we have because it is relatively cheap and more or less ubiquitous. And therefore, we need to consider if we are all willing to make a different choice. But it's absolutely right to your point. I think I mentioned that yes, the system is working too well. And in other countries, if you were to start from scratch or at least from a relatively low level and then really deploy and transportation energy system, gasoline might not be the most forward-looking option.
Yep. Part of this thing is what's already there. So I grew up on a farm, and we had to have our own gas tank, of course.
Mm-hmm. Right? Mm-hmm. Yeah, yeah. Because the gas station, because energy supply you had to bring in, and then it was your choice what you would bring in, and basically gets your needs covered. Right. Mm-hmm. Exactly.
We ski at a place that's 30 miles from the nearest gas station.
Mm-hmm.
You know, it's electricity.
Yeah. Mm-hmm. Absolutely. I guess we are at the top of the hour, 10 o'clock. I want to make sure that everyone has enough time to replenish and go to the next tutorial. Thanks for the discussion. Enjoyed this a lot.
For more, please visit us at stanford.edu.